Easy, right? Let me ask you guys a question. Let's see whether that you guys will know the trick or not. I'm gonna make a problem somehow, and then I will ask you what will be the output out of this, just like for fun, right? What you should expect actually in the quiz, it will be chapter 1, right? Number system. And also you should expect getting the chapter 2 with Boolean algebra. Right? And the gates, right? Equivalency thing. You remember the gate equivalent with NAND gate and all the things, right? How the quiz should look like. Normally, quiz, you're gonna have like half an hour questions or 2-3 questions. I don't know how it's gonna look like. And then, you will just get it and you will continue the lecture, right? But, because we are in a pandemic now, it's really quite tough on you. So I'm gonna give you a very good offer. What is the offer? I'm gonna release on Wednesday morning the quiz, and then you have up to the midnight to submit your quiz into the grade school. Fair enough?
Thank you. Yeah, appreciate that. Thank you.
Yes, so you're gonna have up to, until midnight to submit your own answers on the grid scope. Then I will go into the grid scope. I will start grade you one by one, and I release it individually to everybody. Then you will look at it and you will see that, here's your grade. And of course, breaking into pieces, why you get this, why you get this, why you get that. And then if you have any questions, you can, come and say, hey, I have this question, I have this questions, can you help me with it so I can just clarify. Sounds good?
Yeah, and we turn it in on Blackboard, right?
Oh, exactly. I will put also the grade on the Blackboard as well. So at least you will know the portions left for you up to the final grade. Right? Based on the syllabus we already have. Sounds good? Christopher? Do we submit the grid scope? No. Let me tell you the story. You guys never use grid scope, right? It's not the end of the world. You know what? I have a good offer for you. You guys like computer vision?
Yes, yes,
Okay.
yes.
Good. Take this link and go into the there is a competition or something. You put your name, download, just follow the steps. You might win a neural stick like this one for free. It actually costs $170. So if you get it for free, it's for fun. Then you can learn it by your own. So look at the link I sent you.
Thank you.
Okay, so I want you every day or every couple of days to look into the hackstar.io, and there is a bunch of giveaway. So they give you away for free, and they ship it for you for free. So, it's cool to learn something out of it, right? Anyway, back to the future. That's not our importance. That's not our important. So we are here in the 2300. Pretty much on Wednesday morning, you will find that, there is a folder, and this folder, I actually make it for you now, it's called Quiz 1. Under this folder, there will be 3 files. Okay? First file, it will be the transformations of the grid scope. So let me actually pick it from the last summer. And I put it there. Courses. Midterm 1. So instructions. Copy. Now we are 2300 what? Full, right?
Yeah, 2300 fall 20 and section 2.
Can you see it? Don't see it at all. Here, right? Okay, and here's the quiz, and they submit. So I'm gonna go inside grid scope. This is the grid scope, and then I will put the list of your names there. Then automatically grid scope will send you guys individually emails, say that, you know, create a username, password, stuff like that, right? You will follow the emails and you will be able to access the grid scope, right? Then leave the grid scope aside and you return it back to the folder I mentioned in the Blackboard, right? So you're gonna go here, 2300, and then, you know, from there you're gonna go course document and you're gonna go look into this quiz one, right? You will go there, you will find the exam with two different formats. One as a Word format, one is as a PDF format, okay? Every question I will give it to you, I will leave a space for you to answer into after the questions, right? You will use, you know, like, do you have like a notebook? Do you have a tablet with stylus? You can write by your hand and in the designated area, right? If you are not a person like that, what you can do, you can go in a Word document and you will start type with Word. Then how can you draw? There is a ton of the drawing gates you can find, you know, on internet, right? Like drawing gates software, logic gates. There is a ton of them. Like, look. Then Word, and after that you convert the PDF, the Word to PDF. That's easy. In the Word, you say save as PDF, it will be PDF. You will go and you load it into the grid scope, then you are done. That makes sense? And it sounds easy. This one is fun. I'm not sure if it's for free or not, but it seems fun, you know. Look, it's almost like even better than my handwriting, you know. Okay, so any questions so far about the formalities of the quiz? The rest of the nation? What about you guys? Do you have any questions so far? Malvin, Jeremy, Christopher, Luai?
I'm good. Sounds great.
Oh, I just wanted to double check. So we're just gonna make for the questions that ask for like logic diagrams, we'll make it in that sort of on that website, and then we'll paste it into a Word document and submit it.
You can do this, or you can draw by stylus. Do you have a stylus? You know, like, you know, the stylus I use while I'm talking to you guys.
Yeah.
Yeah, you can do this, right? You can draw by stylus, right?
Yeah.
That makes sense.
Mm-hmm.
I'm just giving you multiple options, right?
Yeah.
Yeah, that's basically what I want to say, you know. Okay, so let's stop sharing and we'll talk back about, you know, what questions we might have, right? So what questions you guys would like me to give you? So numbers, you know, to number, you know how it works, right? Let's say that, you know, you have decimal, you move into binary. If you are integer, you actually divide them by 2. If you are in a fraction, you multiply by 2, and, you know, the other side go up and down, right? You know this, right? If you move from decimal to a new system I invent for you, like 17th system, what you gonna do? You're gonna divide by 17th, right? That's basically the whole concept thing, right? Do you remember the parity bit? Do you remember do you remember the one bit full adder when we discussed, and then, you know, we made the critical passes and stuff like that? Those stuff, you know, are most important. Boolean algebra. So maybe, you know, I give you an example. Let's say that, you know, I build this following circuit.
Professor, I don't know if you're supposed to be sharing screen.
I should actually share screen with you. You're right, but I don't know why this thing is not actually sharing screen.
Oh.
It's being annoying, you know, I don't know why. You guys can see anything?
Yep, that was good.
Yes.
Click it now to say A, B. Somebody can tell me what the output of this should be.
One.
I believe it's 1.
Who said 1?
Blue eye.
Do you think it's 1?
Yeah.
Honestly, I just look at the lower function and the answer is 1, so that's all what I care about.
It is 1. You know why? This guy is 0, right?
Mhm.
So 0 was 1, this is 1. Anything ORed with 1, it will be 1.
Mhm.
So you don't need even to think about this one. I haven't talked about the K-map yet, so don't worry. Okay, that makes sense. So see, I'm tricky. This is all tricks I do. You can have a jungle of gates go into each one, and be like, what the heck? What this guy he wants? Then your eyes has to be like a very good enough to say, oh, here's the branch he wants to talk about, right? Questions about K-map, like Mike said, that's a very easy practice, right? I can just give you a certain equation and then go ahead and optimize it, right? Let me give you actually something which is more fun. In a K-map, we said the 2 variables, 3 variables, and 4 variables. Do you guys remember? And we talked about the don't care. You guys also remember? Right? What about if we talk about 5 variables? How it gonna work?
We make 2 4-variable K-maps.
Exactly. How are we gonna do it? I can show you. Let's have a practical example. So the practical example we can have is the following: 5 input majority encoded. So that means I have a box. It has 5 variables input: I0, I1, I2, I3, I4, right? And then here's the output. Let's call it OB, right? And that's called majority for ones. I made the majority encoder before in front of you, right? So at the end of the day, we have I0, I1, I2, I3, I4. So how many states I should have in this table?
$32.
32.
22, correct?
Oh man.
Exactly. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? Let me show you something crazy a little bit. Okay? So which is basically 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Then 1, 2, 1, 1, 1, 2, 1, 1, 1, 2, 1, 1. And then 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 3, 4. Then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? Then we can come and say there is something called I41, which is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So I make it in 16, not 32, right? Let's wait and see. OB0, OB1. What does it mean? When the I4 is equal 0, that's first 16. When the I4 is equal 1, that's gonna be the OB16. So 16, 16. So see, because I don't want to make a big table and time myself, right? So let's look at it, right? Those are those all zeros gonna be zeros. Just 1 in front of 4 zeros is still 0. Then 1 also. 2 in front of 3 is still 0. 1 in front of 4 is still 0. 2 in front of all of this is going to be 0. 2 is still 0. And then 3 in front of 2 now is going to be 1, 0, 0, 0. And then 3 is going to be 1, 0, 1. Oh, I'm sorry. I don't know what happened, but you know. 1, 2, 3 going to be 1. And then 4 is going to be 1. So far, so good. You guys agree with me? Now we're gonna go ahead and take the other one, right? Look at the other one. Now 1 with all of these guys is 0. 2 of all of these guys is 0. Of course, you are not talking about this anymore, right? So let me make a color like this. You exclude this in your head. Not there, right? We're taking the other one, right? So now 1 with 1 is gonna be 1, 0. Then you know another 1 with those guys are gonna be 3, 3, 0. And then you know 2, 0. And then you know 3 in front of 3 still 0. And then you know 3 in front of 3 still 0. And then you know 4, 1. And then 2 are gonna be 0. And then you know 3 out of it 3 is still 0. And then you know 3 out of 3 is still 0. And then you know 4 is gonna be 1. And then you know 1, 2, 3 still 0. And then 1, 2, 3, 4 is gonna be 1. And then you know 4 is gonna be 1. And then now it's 1, 2, 3, 4, 5 is gonna be 1. You guys agree? So far so good? Perfect. Now, what we need to do is a little bit tricky. Okay, we need to build something really tricky. 1, 2, 3, 4. Those are the 4 variables we are talking about, right? Don't worry too much about I4 now. Okay. So you are taking those 4 in front of those guys. Okay. So we need the 4 variables thing. So I'm gonna be here 1, 2, 1, 2, 3, 4. 1, 2, 3, 4.
Professor,
Yes, sir.
the third one, is it 1 or 0 from output 0?
Which one?
So OP0, the third one.
OP0. This one. 1, 2. This one.
Yeah.
And this one is 0 still, right? Because you know 1, 2, 3, 4 zeros in front of 1, so it should be 0. You're right. Okay, now so we have what I3, I2, I1, 0, right? I3, I2, I1, I0. Then 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Remember that? 0, 1, 3, 2, 4, 5, 7, 6, and then 8, 9, 11, 10, 12, 13, 15, 14, right? Now we are looking, right? So the only one we have is this guy, right? Which is 7, right? So 7 is 1. What is this guy's? 11, right? 11 is 1. 11 is 1. And then this guy is 13 is 1. 13 is 1. And then 14 is 1. And then 15 is 1. That makes sense? Everybody agree? And then you can put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many groups should have? Somebody tell me. Remember when we said 16 can be 1 by itself, 2 groups, or the 4 groups, or 8 groups, or 16 together, right? So maybe we can ask Melvin. So how many groups should they have?
Sure. Right now it looks like there's 4 groups of 2.
4 groups. Okay. Yeah. So Juan, do you think he's right?
Yes, I think it's 4 groups of 2. Because you can't group with 3s. It's only powers of 2s.
Greven? Do you think they are right?
Yes. Because there's no other way to do it as far as I can
So
tell.
this is group you mean, right? And then this is another group, right? And then this is another group you mean, and then this is another group you mean, right? So
Yes.
did I do correct? Should I get the grade?
I believe so.
Okay, thank you. Appreciate it. So now we're gonna be group 1, group 2, group 3, and group 4. So pretty much we can come and say OP0 as a function of the I0, I1, I2, I3, and I4. I4 is the one who's responsible in this, right? When I put zeros, right? Is equivalent to group 1 or with the group 2 or with that 1, 2, 3, 4. Group 3, group 4. Maybe somebody can help me to spell it out. So group 1, what the output coming out of group 1? Griffin, can you give me the group 1? Griffin? Maybe you can ask somebody else. You know, I ask you.
Would it be I3, I1, I0?
For the group 1?
Yeah.
Let me check with you. Let's see whether that is correct or not. Right? Do you agree?
Yeah.
Okay, so that means it's gonna be I3, right?
Mm-hmm.
I3. Then you know we're gonna go vertical, right? This. It's gonna be I1, I0, right?
Yeah.
Is he right?
Yes.
Yes.
Super. Okay. So who would like to do group 2?
I could do group 2. I got I3, I2, I1.
Wait, let me write you fast. You're faster than me.
Sorry.
No, I'm just joking. Come on, anyway. You're doing good. Anyway, group 2.
So I3, I2,
I3,
I1.
I2, and then up it will be I1 or I0?
Let me double check, but I think it's I1.
You're right. Great job. So let me pick somebody to do the Christopher. Give me group 3. Christopher.
Hello?
Yes. Can you hear me? Go ahead.
Group 3, right?
Yes, sir.
I got I3. Wait, sorry.
I3, yes, go ahead.
Am I looking at the right one? Okay, yeah. I3, I2, I0.
I2, and then, you know, I0. Is he correct, guys?
Yes.
Okay.
Very.
Yeah, very good. Nicholas, can you go ahead and give me group 4?
Yeah, I got A, B, C. Oh, sorry, it's in different
Huh? Nicholas?
different variables. Yeah.
I cannot
So
hear you. What did you say?
I use different variables. So I think. Do you mind scrolling up just so I can? I think it's I3, I2.
1 second, let me write. She said they're gonna be I3. Don't forget this is the group, right?
Actually, sorry. I2,
I2.
I1, and then I0.
You think is right?
Yes.
Okay, so we finished the first task, which is the OP0, right? Let's go to the OP1, right? So OP1, we need to figure it out. So we're gonna make our own table for this. 1, 2, 3, 1, 2, 3. Here is the I3, I2, I1, I0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, right? 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. You guys agree? Now we're gonna go into this OP1. So we are talking about this element, which is basically 7 also, right? It's 7. Then we have this gentleman, which is also what? 1101, right? That's what, 11. Where's 11? Then we need this one, which is 13. Then we need 14, 15. But there's something also is missing here, right? 1, 2, 3, 4, 5. 1, 2, 3. It's correct. 1, 2, 3 is correct. It's correct. There is correct. There 1, 2, 3, and there is 2. No, this is not correct. Did you see what happened? I have an error here. You guys didn't recognize it, right? Did you see what happened? Hello? Yeah.
Yeah.
I
Yeah.
believe there's another one, Professor.
Yeah, I know there is multiple ones, so that's why we need to do the OP1 again. So look,
Yeah.
0, 0, 0, and 1. So that means 0. 1 and 1, and there's 3 zeros, still 0. 1 and 1, there's 2, and there's 3 zeros, still 0. Then this 2 and this 1 is 3 in front of 2 zeros, now is 1. Right? Now, 2 ones in front of 3 0, 0. Then 2 and 1, 3, that can mean this also 1. Do you see what happened? 2 of those with that 1, so it can mean 3 in front of this 2, that can still also be 1. So do you see? It's a significant change, right? Now, 1, 2, 3, and 4, perfectly 1. Then, 3 in front of 2, 0. 1, 2, 3 in front of 2, no, this is 1. Right? Then, 1, 2, 3 in front of 2, this is 1. Then 1, 2, 3, and this 4, 4. And then 1, 2, 3, 4, 4. Then 1, 2, 3 in front of this 1 and 1. See? Completely changed, right? So now we can look at it in a different way.
Professor?
Yes.
Okay, so the last 0, I believe it's 1 as well.
This one? Let's see. 1, 2, 3. Yes, it's 1. You're right. Okay? So pretty much we can write it in the side here. 0, 0, 0, 1, 0, 1, 1, 1. No, that was 1, right? Yeah, 1, 0, 1, 1, 1, 1, 1, 1, 1. And then we can come here and just see this. Right? Then we can go ahead and just like sounds good. Now we can look into the table now. So this is basically what? 1, 1, 0, 0. That's 3. So that's M0, M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, M13, M14, M15. You agree? Now we're gonna go and say, okay, M3 is 1. M3 is 1. M5 is 1. Okay. M5 is 1. M6 and 7 are 1. 6 and 7 are 1. 6 and 7 are 1. Then M8 is not. M9 and M10, 9 up to the 15 are 1, right? So 9 Where is 9? 9, 10, 11, 12, 13, 14, 15. Okay, now we just have the 0 and 0 and 0 and 0 and 0. That makes sense? Somebody tell me, what should we do? How many groups should we have?
I think it's like 6 groups. 4 of them can be grouped of 4.
Yeah, let's see. So this is a group, right? This is a group, right? Now
You can make 2 4s with
1, 2, 3, 4. That's 6, Russ.
Wait,
Correct.
Professor, can't we group 4 to make it easier on us, even though it's redundant?
You're right. That's also correct. I'm just trying to see how we're gonna do it. So let's do it. So now he is right, actually. It's different color here, right? We can do it like this. And we can do it like that. And we can do it like this. And we can do it like that. You're right. Because as much as you can group in a bigger number, that will make it actually easier for you and you simplify. Yes. So is this clear to everybody? What we did? Sounds good. So now we have OB1, and you guys can figure it out. It looks very fun, right? Do it as a practice, right? So do you want me to do it, or you guys would like to do it by yourself? It's up to you. Should we do it?
I mean, give me a minute to do it real quick. I think I can do it.
I agree.
Okay, so you guys can do it. Okay. Now there is something I need to build in front of you. We haven't finished the circuit yet, right? We just built OP0 and OP1, but we need the final, right? The table was actually both of them, right? And we didn't use I5 at all, I4 at all. Do you agree? So so what we need, actually, we need a circuit like this, an AND gate between of the OB0 with a selector, which is I4, and we will do this one like this, and that will be the selector with the OB1, and an OR gate is gonna give you the function of the whole interaction. Let's see if I'm right or not, right? If I4 is equal 0, if I4 is equal 0, everybody look at this, right? So put 0 here, so the output here will be what? 1. Do you agree?
Yes.
Anything ended with 1, the output will be what? That same. Right?
Yes.
So in that case, it's gonna be OB0. Then that's 0. Anything ended with 0, the output will be what?
0.
0. Anything ORed with 0, what the output will be? That same. Right? Let's change I4 to be 1. So here we're gonna change the color into different one and say I4 is equal 1. So the output here is 0. So anything ended with 0, it will be 0. Anything now here is 1. So basically 1. Anything ended with 1 is gonna be OP1. Then any 0 going with OP1, it's gonna be OP1. Yay, we fixed it. Later on in the other chapters, we're gonna move forward. This circuit, you can remove it and you make a symbol look like this. And output, and that's actually 0, and there's 1, and that's called multiplexer. So what we built actually was multiplexer. That's in the chapter combination circuit.
I'm sorry, can you repeat that last part? It's called a multi what?
Multiplexer. We stand for mux. So multiplexer. Multiplexer.
All right. Thank you for the spelling.
You are welcome. It's like, you know, do you remember the full stop sign when we are driving in the car, right? 4 of us came at the same time. Who's gonna actually proceed? The one who came first, but if all of us came at the same time, the one on the right, right? So the same thing. This is a selector will pick up, you know, whether that you're gonna go this way or you're gonna go this way, right? So did you see what happened? You're gonna build the circuit of the OPZ0, this one, with bunch of gates, and you're gonna build the one with the OP1 with bunch of gates, and then, you know, the wire coming of OP0 will go into here, the wires coming from OP1 will go there, you continue with this end and whatever up to the output, then you will get the final output of the majority. That makes sense? Did we learn anything out of this? Multiplexer, XR, ER, not OR. Multiplexer. Okay, Duke. Any question? Melvin, do you have any questions? As he said, oh.
Yeah. Oh, not about the multiplexers.
It's about
I
how
guess
big
we.
it is.
Yeah, those are annoying. But you just derived this logic expression in front of us, and you just can you go over that again? Because that was
No, I can make it actually better for you. How
Okay.
can you build in a set of 3 variables, something coming from 4 variables? Symmetric, right? Majority encoder 4 bits. How are we gonna build it? Using 3 variables K-map for optimization. You see that? Here. So I have a table like this. I0, I1, I2, I3, and here's the output. And that's called majority for the ones. Sounds good? Now, since I have 4, so that means my table would be how many states?
16.
16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1. 1, 2, 1, 1, 1, 2, 1, 1, 1, 2, 1, 1, 1, 2, 1, 1. And then 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? Now I want to have my majority. Just an 8. Yeah. I'm looking for the ones, right? Presence of ones. So that's M0, M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, M13, M14, M15. Right? Now, first state, 0, 1. Melvin?
Yes.
First state is what? The output.
For M not? Oh, M. Okay, yeah.
Yeah. We just have 1 in front of 3 zeros. 0. 1, 0. 2 in front of 2 is still 0. 1, 0. 2 in front of 2 is still 0. 2 in front of 2 is still 0. 3 in front of 0, 1 is 0. Then 2 in front of 2 is 0. Then 2 in front of 2 is still 0. Then 3 in front of 0 is going to be 1. Then 2 in front of 2 is going to be 0. Then 3 in front of 0 gonna be 1. Then 3, 1. 4, 1. So far, so good?
Yes.
Okay. If I look to this, and I want to make it with K-maps 3 variables, right? First of all, I don't need to make actually the first K-map. Do you guys agree? Why? The first K-map is covering from M0 to M7, right? The M7 is the only one by itself. Do you guys agree? This is good, right? So pretty much I can turn right here and say OB0 is equivalent to M7, is equivalent to I3 complement ended with the I2, I1, I0. Does it make sense?
Yeah.
Completely honest? No. Wait, oh, you took that. Okay, 1 minute. So you took the output and then you compared it with. Give me a sec. I'm sorry. I'm looking at it. Okay, I get it. I3 complement I2.
Yeah, because I call main
Yeah,
term, right?
Yeah, okay.
And then the only one in the map is equal 1. So no need for actually making the map, right? Do you think it makes sense, or should I make it on the map?
No, that makes sense. M7 makes sense.
No, that's not fine. What about the rest of the people? Benjamin. Benjamin, what do you think? Perfect. Austin.
It makes sense.
Christopher. Who's Christopher? Are you the guy there? Hello. Andy.
No, it makes sense.
Okay. Vincent.
I got it.
Andrew. Okay. Landon.
Yeah, it makes sense.
Okay. Anyway, now we are gonna make for sure the second K-map. Look, dense, right? So second K-map, it's very easy like this. 1, 2, 3, 4. Here is gonna be I3, not I3. I'm sorry. I2, I2, I1, I0. 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, 3, 2, 4, 5, 7, 6, right? Let's have the values. So basically M7, not M7, I'm sorry. They're gonna be M3, right? This is my M3 is equal.
Mm-hmm.
Then this is gonna be M5, right? And then this is M6. This is M7. Let's remind you what with the carry out of what of the 1-bit full adder, right? How many groups you should have here?
3.
3. So pretty much you can write it. It's really easy. 1, 2, 3. So you can come and say OB1 is equivalent to what? It's equivalent to I2, I1 with I1, I0 with I2, I0, right? Do you guys agree? Does make sense what I did?
Yes.
Super. So now we already have OP and we have the other one. So if I would like to build a circuit for this, that's not really hard. So basically I would say that I3 complement ended with I2 while I'm ending I1 with I0. And that will be ended directly to get me what? to get me the OP0. That makes sense? Then I1, I0, this one, nope, took it as it is, going to be ORed with the I2, I1, right? So we can have a different color. I2, I1, and it, and that will be ORed, right? Then the third one, I0, I2, right? So we can just go ahead and say what? I0 is I2, and then you know you all this together. That's gonna be OB1. Now it makes sense so far. But those are two outputs. But you know the circuit is actually majority for one output, right? So in that case, you know we need extension. But you know I already use the whole entire thing. So I'm gonna make extension in the button here and say, you know, here a wire coming from the OB0, here's a wire coming from the OB1, and then you know boot number I3 didn't use. So basically, I can come and say this is ended with the negated I3, while the I3 you're gonna do it like this, or it, and then gonna be the F. This should be here. So far so good. Now it makes sense, Melvin?
Yeah, that makes more sense. Thank you.
Zach. Zach.
Yep.
Yeah, that
Yep.
makes sense?
Yes.
Diego.
Sounds good, Professor.
Thank you, appreciate it. What about you, Jimmy? Jimmy Vaughn.
Yeah, it makes sense to me.
Okay, super. If you guys have any questions, let me know. If not, I think it's enough for today. Since you know exactly what we're gonna do. So we know K-maps, you know 3 variables, 4 variables, and 2 variables. More than that, you know you have to make a play and manipulations. Boolean algebra, you know it exactly, right? And what is the other one? The number systems, we already cover it very well. And you know the best way for you guys to practice. As we said, the book actually I'm using, I already give you a, you know, you guys found a copy, not me. So you guys found a copy and you know you have it on the Slack, right?
Thank you. Yes.
Yeah, super. Okay.
You said, I'm sorry, you said something about the I3 was neglected, right? That's the correct term, that's the proper term?
No, I mean, OB0 doesn't have any I3 here, right?
Yes.
OB1 doesn't have any I3 somehow, right? But they actually got the decision of it, right? So we need to get this to OB0 and OB1 using the I3 controller, right? Because if you notice in the table, right, 8 positions, I3 was 0, and 8 position, I3 was 1.
Okay.
And if you look to it very well, you would be actually laughing. You know why? Look, when this is actually 0, right?
Mm-hmm.
This table is exactly replica of this one.
Oh.
Have you noticed?
Oh. That's awesome.
You know what? Let's have even more fun. Wait, I will tell you a trick. It's more fun. What about if you decided I3 and I2 to be out of this? Look what will happen. This one is the same like this one, is the same like this one, is the same like this one, right?
Yeah, it's the same.
Exactly. While what? While what? This one zeros. This one fixed, 0, 1. This one fixed, 1, 0. This one fixed, 1, 1. Right? Do you see what I did?
Yeah, I saw.
So now I can make it actually with the K-map 2 variables. But they're gonna be 4 outputs, and then you know we have to make a circuit with combination between I2 and I3.
So that'll be a 4 to 2 multiplexer, right?
That will be 4 4x1 multiplexer. Think about it. I will tell you. Wait, I'll tell you. Since we have here combination of 0, 0, or 0, 1, or 1, 0. So basically, we can make a table, right? And say I3, I2, 1, 2, 3, 4, right? 0, 0, 1, 0, 0, 1, 1, 1, right? Then you can come and say, OB 3, OB2, OB1, OB0. Make sense? Okay. If it's 0, 0, that means this guy will be the one we are talking about. If it's this one, that means this guy is the one we are talking about. If this one, this guy, we are the one who is talking about. If this one, we are talking about this guy. So we build decoder. That's something in chapter 5.
Oh yeah, I noticed when you wrote that. That's a decoder.
Yes, it's gotta be a decoder basically. You're gonna have a box like this, 2 inputs and 4 output to control 0, 1. But this is not, this is not the position for discussing combination circuit. I just want to let you know that you can imagine anything using gate level implementation, right? It's just a table and you put it in, right?
It's pretty cool.
Any questions?
Yeah, Professor. So no full adders on the quiz, right?
The full adder?
Yeah. Or will we have full adders?
Yeah, we can make a full adder. So what? Let's make it. Oh, we have some time,
For the quiz?
No, I mean, let's make it now. Let's see why
okay.
full adder is not.
Sure.
Full adder is very cute. Think about it the following, right? Here is full adder, right? A, B, C, N, sum, carry out. That's 1 bit full adder. Do you agree? In that case, we have A, B, C, N, and then some carry out. How many steps we have?
8.
4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Right? 0, 0, no, 1, 0, 1, 0, 1, 2, 1, 1, 1, 2, 1, 1, 1, 2, 3, 4, 1, 2, 3, 4, right? And 0, and 1, and 2, and 3, and 4, and 5, and 6, and 6. What is the summons? 0, 0, 1, 0, 1, 0, 0, 1. Okay, and then here is 1, 0. Here is 0, 1. Here is 0, 1. Here is 1, 0. Right? 3-bit variables you can build S and carry out. That makes sense? Does it make sense, guys?
Yes.
Look at this fun, actually. I like fun. What about you guys? Like fun or not? How many of you guys favor and fun?
I like fun.
Yeah, I can build this circuit in a very weird way. Do you like to see?
Yes, please.
I like weird stuff. Look at this. If I exclude A, right? How many tables we have in this thing? We have 2, right? What I'm giving you is not even exist in any book. It's not even exist in internet, That's because I like digital logic, so I make stuff, So look, does it seem weirdo to you, or it does make sense? Yeah. Somebody tell me, what is this? For the S, at least. So the first table is providing S as an XOR, while the second one is providing S as an XNOR.
Yeah, I just saw that.
That makes sense? So I can pretty much build you this by an XOR of the B and Cn, while there is another XNOR like this, right? Then the M need to work. So basically we have to go like this. And that will be A. Does it make sense? Do you guys agree?
Oh yeah. Okay. Wow.
Right? What I want to say, how many of you really like to play with Play-Doh and Legos and stuff like that? Are you guys in fun with playing with Lego sets, building stuff?
Yeah,
If you are, then you know you're in the right place. You know what? Let's do it with the carry out. Look at the carry out. Huh. Somebody tell me what is the carry out in this way, using this weird setup. Huh. Carry out in this case will be like that.
Yeah.
It's like in order.
The first one is just end.
An ORD?
Oh, no, still end. Wait, I'll tell you. Look at this. 1 happen in 1, 1. M is equal 0. Not M, I'm sorry, A. So A is 0. When those guys are ended to each others, it has to be ended. Because this combination, when it comes here, it will be back here. Right? Then you go into this guy, right? This guy is OR gate. Right? So you go ahead and you just make like this and OR gate for B, C, N. Then this is a carrier. Any question? Any questions so far?
Could you explain that second part of the diagram?
Yeah, sure. Look. Here the carry out, right? The carry out is looking to this what? This table, right? 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1. What is this? Okay. Of what? B and C n together. But when this happened, when A is equal what? 1, right? That's basically what I said here. If it's A is equal 1, if you OR this, the output of the carry out will be this stage. What do you guys think?
This is amazing. I'm still processing.
I don't want you to learn to save the stuff in your head. I want you to enjoy what you're doing. Sounds good?
Sounds good. Thank you.
Okay, let me give you, we just have 5 minutes. Okay, let me give you a fancy thing.
Right, and then gates.
Okay, here. Let's build a comparator. If you would like to compare between two things, right? What are expecting the output to be? So first of all, you will say, I'm comparing something with something. We need to give a name to that thing and the name for that thing, right? So I'm expecting maybe those guys are equal to each other. So that means there is a possible output called E. Maybe A greater than B. So I'm expecting A greater than B. Maybe A less than B. So it can be A less than B. And this is the comparator. Right? Now, if I want to make A and B with resolution, what does it mean resolution? That means A is 2-bit representation, B is 2-bit representation. So what table we can have out of this? How many states we should have out of this? Somebody tell me.
16.
16 is perfect. Who said 16? Why or Juan?
I think it was Jung-Ho.
Oh, yeah. See, this guy's tricky. He's tricky more than me. Oh my gosh, I found somebody trickier than me. Anyway, so now it's 16. You know why? Because A is 0 and 1 and 2 and 3, right? B is 0, 1 and 2 and 3. So end of the day is 16. He's right. So you need to make a table like this. And then you would say B1, B0, A1, A0. I'm expecting to have greater, equal, and lower or less, right? Then 1, 2, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? Then you will start filling it. So going to be 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Then there 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. Then 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? Everybody agrees with me? Now, if I would like to make a comparison, I will just stick in my head the following fact. This is 0 equals 0. So end of this, that can be this one. Right? Then I can go back. Here, this is 1 and this is 0. 1 is greater than 0. So basically, it's going to be 1 and 0, 0. Then, this is 2 equals 0. So it's going to be 1, 0, 0. 3, 1, 0, 0. Then 0 and here is 1. So it's going to be less. Then 1 and 1. Then 2 and 1. So greater. Then 3 and 1. Greater. Then 0 and 2. Less. Then, 1 and 2. Less. Then 2 and 2. Equal. Then 3 and 2. Greater. Then 0 and 3. What would that be? Less. Then 2 and 1, right? So gonna be 2 and 1, 2 and 1.
Less.
You're gonna be less, right? So then 2 and 3, less. Then 3 and 3 equivalent. Imagine we finished. Now 4 variables, 3 variable, all the tricks we can apply. Do you guys agree? Right? Should we try to see what we're gonna get out of this? Somebody tell me what should we do? If we would like to make it 3 variables, how gonna look like?
It looks like we have another pattern in the A1, A0 column.
We have pattern, yes, you're right. So look, this is an OR gate, right? Does make sense, guy?
Yep.
This one doesn't make anything. So basically, at the end of the day, it's gonna be combination between them, right? And then this one AND gate. This one ground, just connected to the ground. Right? Does make any sense to you guys?
Yes, it does.
Super. So I hope you guys are enjoying this course. That's basically what I want to say. pretty much, you know how to even move from gate to gate. I want you to stress on this. That's very also important. Quiz, I'm not going to give too much questions, but of course, midterm, we need to work for the midterm into the quiz, right? So that means I want you to start very strong and, get into the point and get A. Sounds good? If you have any questions, don't hesitate to ask, and I will be more than happy to assist you. Okay, Luke?
Thank you.
So if you don't have any questions, I would like to thank you guys for your time and your effort, and God bless you, okay? Stay safe, and good luck with your quiz.
Thanks,
All right,
Professor.
Thank you,
And
Professor.
and
Are we not going to have a class or a lecture on Wednesday then?
it's up to you. You guys in favor of having any class, I can give you a class. If not, I can give you the time so you can focus more on the quiz. Which way you want? Which way you want?
I'm not against having class. I mean,
okay, let's check the rest of the people. So if you want a class, write class.
So would that mean the submission window would be?
It's still till midnight,
Oh, okay.
So you guys are enjoying the class? Thank you. Appreciate it.
Yes, very much so.
Thank you. Okay. So anyway, God bless you. Stay safe, okay?
All right, Professor, God bless. Thank you. Thank you.
God bless. Thank you. Okay, talk to you later. And I'm going to post the lecture now once we close, okay? Thank you. Bye-bye.
Thank you. Bye-bye.
Bye.